Okay. Luigi and Corrado, you can start if you want.
Okay, yes, I start. Let me show my screen. Okay. Can you see my slide? The first one?
Yes, it's okay.
Yes.
Okay, thank you very much. Okay, hello to everybody, and thanks for coming. We talk about Oracle approach to machine learning and deep learning to develop data-driven services. Let's move on. More interesting slide than our Oracle disclaimers. Okay. First, let me briefly introduce myself. I'm an Oracle Cloud Architect working in sales teams. I'm also with my colleague Luigi, an ML and deep learning specialist working on every business related to this kind of subject, enabling customer and partner to demo and architectural design. In my part of the presentation, I'll show to you these subjects, a data science overview, and the data science toolbox, Oracle Data Platform. So I'll talk about our data platform in order to create data science related projects. And I show it to you also some use cases at our Oracle customers. I let Luigi to introduce himself.
Well, okay, that's my picture in 101, my previous engagement. I will talk about deep learning, so neural network, and I will touch some subjects that I've chosen, especially for this event. So I don't want to spend more time on this slide, and I'll leave the slides to Corrado.
Okay. Okay. I talk first of all about data science, and then we see Oracle tools designed to help data scientists to ingest, transform clean data, and create quickly machine learning models and analyze the results. Then we talk about some use cases in Oracle customers, just to have an idea of what we have done with our customer in terms of data science projects. Okay, let's start with an overview and basic concept. First, what is in data science compared with business intelligence? They have in common for us leveraging in historical data and structured data. Data science is also used to manage unstructured and high volume complex data. Differently from business intelligence, it is more descriptive. So you try to find key metrics. In data science, you are interested to predictive and make prescriptive application. Normally, you require the knowledge and application in statistical technique, and you need a lot of skills in terms of coding and software engineering. Methods applied in data science includes for us statistics, artificial intelligence, machine learning, and deep learning. This is a common way in which we divide these methods. In this slide, I put an idea of what we can do, what is normally the typical machine learning design cycle. Because talking with enterprise data scientists, they often tell to me that they haven't problem with the phase model development and model evaluation. But they spend normally 70% of time in the first 3 steps that are very challenging in general in the enterprises. And we will see what we offer to solve these 3 important steps. Finally, who we are addressing when we talk about data science. Normally, data science is the highest skill users of data science, but we have also considered citizen data scientists that have a good business knowledge, a moderate data science skills, but no ability in terms of skill or coding skill or management of data science platform. And we will see how to address also this kind of users. Normally, citizen data science talk a lot with business analysts that have normally, obviously, business knowledge. And we also have business consumers that are interested to consume model and to create dashboard by themselves. So let's talk about an overview of what Oracle offer to build a data science project, in particular a machine learning project. Our data platform service is now completely created in cloud and offer all what you need to leverage every step of machine learning and data science project. First of all, you need to ingest data. So we have managed service like streaming that offer an asynchronous way to put information coming from, for example, from IoT sensors. And this is based on Kafka. So we have a way in which you quickly create a queue in order to get information coming from IoT sensor. The data integration is another managed service that you can use for batch processing. So if you have a lot of data inside, for example, object storage, you could leverage data integration in order to transform and ingest in other silos this data cleaned and ready to be used by data scientists. Data integration is a completely GUI and wizard interface. So it's created to simplify the creation of data flow. Data flow instead is also an instrument to create data flow and ingest and transform the data, but is completely based on coding. Big data service remains a service to migrate great Cloudera big data service, and customer could use to move from on-premise to cloud their Cloudera and big data installation. On the right side, you can see all the flavor that we offer in order to manage in data from MySQL or the open source database, and our database, Exadata, and on top of them, autonomous database that is the best-in-class database that we offer, that is completely self-driven and self-managed by the platform. So you can focus straight to the development and manage of data. On top of that, you can find a data catalog and the tools to create machine learning project. Mainly data science that we will cover by my colleague Luigi, and machine learning inside our database. We also offer an analytics service named the Oracle Analytics Cloud that is targeted to the citizen data scientists. Then we also offer service for graph and cloud SQL in order to access to all data through a SQL interface. Well, first of all, data integration. Data integration so is a fully managed infrastructure service for ETL that simplify and accelerate loading and transforming data to cloud, database, and data lakes. The intuitive no-code graphical user interface make it easier to design and manage data flow. The result of this design that you can do through a visual data flow designer is a Spark job. So you define in a graphical user interface the data flow, and you run this in a Spark job, and you pay just for the time in which this job runs on our interface or our, cloud infrastructure. And this is an example of what you can find inside this tool. You can target or relational databases or object storage, so our data lake for excellence. And you could create a flow that put together all information that you need to create the final data set. And in this step, you can, for example, filter data, clean the data, join more table, or aggregate data in order to create new features in a completely visual approach. When you finish this design that you can do in a graphical way, you create an application that includes this data flow, and you will run this flow inside a Spark job. And you can rerun and schedule this in order to refresh your data and create a new data flow in order to have a new data set to be used by the data scientist. The other approach is completely based on coding, and you can leverage this inside the data science service. In this case, you run Spark job on object storage that for us is our data lake for excellence. I provide to you some details in the next slides. And you can write your flow and runs in using Java, Scala, Spark SQL, or PySpark. And in this case, you will have raw data in object storage, process this, and report that at the end of process inside object storage. This kind of approach depends on if you have, for example, existing Spark apps in Databricks or Hadoop. In the previous case, you can start from scratch to design quickly a data flow and run it on our platform. Then let's move on machine learning modeling phase. What we normally do is extract data from an existing data source, for example, as a flat file, run your training or inference on this data. And in case of reinferences, you resubmit the result to the same or other data source. There are a lot of issues in this approach. First of all, you have a problem of latency. You have to transform your paradigm in Python or R in a data access language. So you normally write SQL code in order to access quickly to the data source and recreate the data source in R and Python. You also have a lot of problem in terms of memory limitation by client side, because you need in-memory processing, because you get the data from data source and put it together with the machine learning algorithm and run this on your side. Normally single thread, and you have a lot of problem also in terms of security recovery, because this data comes outside from the data source in which you have stored normally. So this approach normally companies don't like. So we have implemented our algorithms inside our data source, that is Oracle database. You can run these native algorithms using procedural language SQL, that is the common access layer to our database. But recently we have also introduced Python as interface to these native algorithms that we have implemented inside the database. You can also leverage R in case you are running a database on premises. In this way, you have a native HPC environment made to manage data. The relational database Oracle, that can scale with a single instance up to hundreds of CPUs without moving data from their source. This isn't a new approach from our side, because we put database algorithm, machine learning algorithms, I think decades ago. And we have increased the number of algorithms available in order to leverage the new algorithms released by Latitude. From this point of view, Oracle Machine Learning is, first of all, automated. Several processes inside the algorithms are automated. For example, in cleaning data or normalize data, or put, for example, the missing parts, mixing data inside the original data set. This process is made automatically by the algorithm. We are also going to release these algorithms, not only to run on top of database, but you can use also this algorithm through a REST interface in order to run the inference based on this algorithm outside the Oracle database. In this slide, I have put all the algorithms that we have developed and put natively inside our database. You can see that we have probably all the algorithms that normally are used. And we have also some proprietary algorithm like MSET SPRT, that is an anomaly detection algorithm that it has been used by decades in, for example, nuclear plants or aviation, in order to detect anomalies before they happen. And it is available inside our database, together with the normally algorithms like XGBoost, neural network, classical clustering, anomaly detection, association rule, and so on. And these algorithms are available also in SQL and Python recently. Just to have an idea about this environment that is available inside our autonomous database that you could use on Oracle Cloud, and also we have access to a free instance if you want. At the end of this presentation, we will provide the reference in order to create this kind of database and use for free inside Oracle OCI. Let me move on a quick demo that I have prepared. Okay, this is the environment that we offer inside our database. You will find the notebooks available, and you also will find templates and a lot of examples that you can run to quickly arrive to a model trained on our database, using obviously your data. The notebooks are based on 𝗤𝗎𝗄𝗏. In this case, in the data science, we will use instead 𝗙𝗎𝘎𝗎𝗢𝗏. And for example, I'm going to show it to you Oracle Machine Learning notebook based on 𝗤𝗎𝗎𝗏 that leverage our feature named Auto Machine Learning. Auto Machine Learning is a feature that we have put inside this platform in order to obtain quickly a machine learning algorithm trained on your dataset. With the Python interface, you can, for example, use a normal dataset coming from scikit-learn. And can you see my screen?
Yes.
Okay, sorry.
Yes.
I'm just checked because I've switched the application. In this case, you can see that you can leverage scikit-learn datasets, and then you can create on the database a table that include the dataset that is created using Pandas normal API. We also offer the ability to create from an existing database a Pandas data frame in order to be used as you normally as used to manage your data. What I can show to you is, for example, how is the process to first of all select an algorithm. If you have created your data set and established the target and the feature to train, we have on top of our database this API to select in an autonomous way the best classification algorithm applied to your data set that you can see here. The result is a list of algorithms that best fit your training, and the result could be used in the next phases of the development of machine learning algorithm. The next step that you can apply using our automatic feature is the feature selection. So in order to reduce the number of features that you normally do when you create a machine learning algorithm, you apply the selected algorithm that comes from the previous step to your data set, and you will find at the end the best feature that you could use in the next phases. So you can reduce the first 13 features to 9 features that are the main important feature in this case. At the end, you can also tune the model in autonomous way. So you can leverage the selected algorithm, the reduce data set with the feature find at the previous step, and you will find the best already tuned model applied to your data set. You can also do this 3 operations in just 2 lines of code. You simply establish which kind of operation you want to do, for example, classification. You will provide the data set, the target, and the other parameters in the search. And with this 2 lines of code, you will find the best model applied to this data set. Obviously, if you have a large database, a large data set, the research could take a long time. So we also offer the ability to restrict the search space for algorithms. So you can, for example, research algorithm only on random forest, or in this case, you can search in a neural network, establishing the range of nodes, the hidden layers, and the all activation stuff. So this offer to you a quick way to create the algorithms, and the same is available also on a data science service that will be shown by my colleagues Luigi. Then let's come back to the slides. Okay, we have already seen this. I offer to you this slide in order to have the reference about what you have shown inside the demo. And let's talk about another way in which you can manage your data to have a quick interface based on BI that offer to you tools for the so-called citizen data scientists. In this case, we are using Oracle Analytics Cloud. That is a machine learning also platform for business analysts. You can try this by yourself, this platform, with the link that I provide in this slide. You can download the desktop application that you could try on your desktop in order to understand how it works. For this kind of tools, let's come back on a quick demo that I have prepared for you. Okay, this one. Sorry, okay. This is an example of what you can do with this tool. This is a BI tool, a classical BI tool, but you can augment your analysis using some algorithm, machine learning algorithm. In this case, for example, we are trying to cluster this data set. To do this, a citizen data scientist, without knowing nothing about, for example, k-means, they can just click on this canvas and can choose the kind of algorithm that he could apply in this case, and establish how many, for example, cluster he need to analyze, and let that immediately the tool cluster in 3 segments this data without knowing any kind of information about k-means algorithm and without writing any kind of codes. Another example of application, visual application of machine learning inside the Oracle Analytics Cloud is represented by these other two canvas. For example, in this canvas, I have created a trend line using a method based on PoliMi. We also use a linear methods, linear trend. In case, for example, of polynomial, you can establish how many degree you want for the curve. And you can also see the confidence interval that has been established, 95% in this case. In case of, for example, time series that is represented in this canvas, in this case, you can do forecast. Simply applying one of the machine learning algorithms available, for example, in this case, seasonal ARIMA, that you could probably know. And you have to establish on the original data set that is this, how many days, in this case, you want the prediction. The tool automatically provides to you a prediction on the next 20 days using the data set that you have provided. So this kind of tool offers to you a quick way to approach machine learning, and it's the target of this kind of tool is the citizen data scientist. In this tool, you can also transform data and, for example, apply a machine learning algorithm that someone has built on top of autonomous database and apply to his data, for example, an Excel spreadsheet, and create their analysis based on this algorithm that is on our autonomous database. It could be consumed inside a data flow that you can run on this platform. Okay, let's come back to the slides. So at the end of the day, what we provide to the customer is a new approach to a modern data lake, in which you could merge all this technology to create a very flexible platform in order to manage petabytes of data without any complexity in terms of operation site. So first of all, you can move your data, your raw data, your Parquet files, your CVs on CVS, sorry, files on object storage. that is built to scale at petabytes without any problem. All data that you put on object storage is replicated across the cloud, so is absolutely secure in terms of reliability and security access. And this data that are put in this data lake at low cost without any kind of management by you. You can simply drag and drop your data on upload through a console on object storage. And from that moment, it's our problem, Oracle problem, to maintain your data in the right way. The object storage could be used to virtualize this data. For example, 𝗙𝗏𝗢𝗀 file that come from a big data data lake. And you could virtualize as a relational database table. So the common access interface, like Oracle Analytics Cloud that I've shown before, or OCI Data Science that could be used to get this data, will access to a data that is represented in a relational databases. So in this way, you could also merge in the database partition, so data that are fresh data coming from latest upload that you could analyze or create a new data set for your training or your inference, and leave all your data, historical data coming from external sources in external partition. On top of this, you can run Python or PL SQL machine learning algorithms, and you can offer this algorithm to, for example, Oracle Analytics Cloud, or let that data scientists that want to approach with open source algorithms, this data in order to be used as data set to be used also for training or inference too. This kind of architecture has been used in several of our references that I'm going to show to you. The first of all is CERN of Ginebra. In this case, they are using exactly the architecture that I have shown to you in the previous slide, based on autonomous data warehouse, in which they have put 1.1 petabytes of data coming from the cryogenic system that is based on 6,000 superconductor magnetics. The information, the IoT messages coming from this superconductor are put through Kafka queue on autonomous data warehouse and object storage. And they use Oracle Analytics Cloud in order to analyze this data, to create a machine learning algorithm to make predictive maintenance. And they have gained a lot of productivity, and they have a lot of success in terms of operational stuff, because they have concentrated their data analysts not on management of a huge database installation, but only on the data and the creation of machine learning algorithm on top of that. Another great success story is about NHS, National Healthcare Service in UK. In particular, we are talking about the Business Service Authority. This Business Service Authority manages around £30 billion budget, and they provide reimbursement to claim. And they have invested a lot in our platform based on a database, running these machine learning algorithms on top of database, to find to try to find an estimated fraud that every year is around £1 billion. Using this approach, for example, on dentist claims, or for example in antibiotic prescription reduced in terms of prescription, they have saved in the first 2 years of this project around 700 $600 million, running machine learning algorithms to analyze the claims in order to find inappropriate claims or fraud in this kind of claims. Another example of using our technology in terms of machine learning is Noble Plastics. In this case, we are in the manufacturing industry. This is a North American inject molder that has around 5 million revenue per year. And this employs 16 robots and runs its plants on 24 hours, okay? So they have a huge problem in order to detect anomaly in time, in order to avoid to produce defect parts of their plants. So because for example in the night this system is unattended, so they usually have used to find the problem the day after the start the anomaly. Using an approach based on machine learning and our Oracle IoT services, they at the moment have gained 17% chance to find a problem on production on bad part in the next 24 hours. So they are able to stop the production, fix the problem, and avoid to create to produce bad parts in their plant. And finally, this is another example of application of machine learning using our data platform. And it's presented by a financial institution that have used graph analytics in order to find fraud, putting together big data graph technologies and the data that are stored on our database with machine learning algorithms. So I will finish my part. If there are any question, you could also put in the chat. So I answer to you, and I leave the control to my colleague Luigi for the next part regarding deep learning approach to our project. Thank you.
Hey, Corrado, just a small thing. There is a link in your presentation.
Yeah.
If you can, please write down in the chat the link so the guys can click on it, because in the presentation it's impossible to click the link. Yeah, thank you.
Okay, in any case, we will share to you and to the attendee the presentation briefly. Okay.
Okay, fantastic. Thank you.
Okay, can you see my slide?
Yes, regarding deep learning.
Okay. Okay, so good evening, everyone. Let's start from this slide. Okay, so first of all, before starting the presentation, I'm going to give you an information. On the slide, you will find very few details because it is normally the style that I prefer, but I will give you access to the script of the presentation. So if you don't want, you don't need to take a lot of notes. Okay, first of all, accuracy is not enough. The goal that a data scientist must set today when developing a machine learning models is to create the best model that allows to make useful, meaningful, and applicable predictions. This does not mean simply creating a model that works and maximizes some quality metrics, for example, accuracy, but it means to create validated solutions that allows to translate predictions into actions. So this is, I think that I think is very important to keep in mind. For example, the Stanford University, the Center for AI Applied to Healthcare of the Stanford University, has created this framework that is called the outcome action pairing. Basically, the idea is that when you design your machine learning model, you should try as much as possible to pair, to align all the possible outcome of the model into actions that can be really applied. So it's not only to try to maximize the accuracy, because otherwise your model can be limited or completely useless. The important thing is to be able to translate all the outcome into practical and useful actions. So it is a matter of evaluating many different aspects. So to understand what are the considerations that can be made, let's try with a concrete example. Imagine that we have developed a model that, starting from a series of vital signs, allows you to predict the probability that a patient admitted to an emergency ward, an intensive care unit, will have an acute event in 30 minutes. So it seems to be a very interesting, very useful model, especially in these tough times. But what should we think if we then discover that the model takes 1 minute per patient to make its predictions? This is an example, of course, and that we have an average of 30 patients in the ICU. So it seems not so applicable. And then another important question that you should make is, how can we provide in real time the data the model needs for its predictions? I don't know if you have ever think about it, but an intensive care unit is a very complicated environment. So it is not enough to build the model and maximize accuracy of some other quality metrics, but we must also think about how to really put it into operation in the target setting. For those of you like me, fascinated by the enormous possibility of applying AI in the medical field, a must-read book is Deep Medicine by Eric Topol. Topol, by the way, is not a machine learning expert. He's a cardiologist and is a director of a translational medicine center. Translational means that the objective is to shorten the path between, as they say, from the bench to the bedside, how to put quickly in operations the results from the research. And he's very enthusiastic about the possibility of artificial intelligence. And by the way, he's a very knowledgeable person on the subject, and it's not really common. Well, in the chapter 6 of the book that I strongly suggest you to read if you are interested, the chapter is titled 𝗙𝗕𝗎𝗪. There are many examples of announcement of AI solutions that would have replaced in a few months, more or less, human experts. But then he comments that very few of these solutions have then proved real validity in the field. So my warning is, be really careful not to think that the job of a data scientist today is already an easy job. Let's get to the point. Data scientists today must have a whole set of tools, theory, methods, data processing skills, hardware and software tools like the one that Corrado has shown in the first part of the presentation, and he must be able to select the right combination that allows him to design and implement a model whose predictions can be translated into concrete and applicable actions with a positive effect on the context in which the model has to operate. Between the software tools, we have the algorithms. Many of you already know that there are many different algorithms that can be used, even in the same field. For some of these, the theory has been known for a long time and are well studied at the university. Others are in very rapid evolution.
That is the meaning. You can read it as the meaning. Okay. So,
sorry. The model we were talking about earlier, remember the prediction of an acute event, is essentially what is called a stratified risk model. A model that wants to predict the probability of an adverse event, dividing the population into many subsets containing individuals with homogeneous characteristics. A model that expresses the probability of such an event as a function of a certain number of, as much as possible, independent variables. You can find example of this kind of model in healthcare, as I said, for screening, for the so-called precision medicine, to select people for medical trials. But we can make example in different fields. For example, you can understand that there is a lot of analogy with another risk model, the model that gives you the probability that an arrested person commits a new crime in a certain period of time, let's say 2 years. This model today are in use, for example, in the United States, in many counties, where judges use model of this kind in deciding whether to apply or not alternative measures to detention. Another example in the financial field, risk models used to evaluate, for example, the probability that a person will not pay the installments of a mortgage or a loan on time. Well, all these examples have something in common. They fall into a general case. We want to derive from the data at our disposal the best possible approximation for a function, the probability as a function of the feature x1, xn. Our algorithm in a situation like this has to work on what is called the structured data, a set of number or sequences of letters that in some way measure the individual on which we want to assess the risk. Well, basically, today we have two broad category of tools for this kind of task: neural networks and the so-called gradient boosting algorithm. For example, some implementation of the second one are extreme gradient boosting or light GBM that are very modern example of ensemble, a large ensemble of models where each model tries to increase the accuracy of the previous one. Well, with not time to go into details for all these kind of tools. And this evening, I want to talk a little bit more about neural networks, but I will give you one example regarding gradient boosting, and I strongly suggest you to take the time to go into details also about gradient boosting. A completely, as we will see in a few minutes, universal tool in theory, but which may have some limits in practice, is neural networks. In the simplest example, a neural network is simply made up of n layers of computational units. A more complex example is the network shown in this second picture that was used, I think, 7 years ago for image recognition. To clarify the terminology, when we talk about deep learning, we talk about using deep neural network with many layers between inputs and output. So the picture is a deep, in this case, a deep convolutional neural network. Well, since we can say that the second part of the, it is nice to say, of the last century, a series of theorems have been developed, and they are called normally as a general approximation theorem. For example, if you are interested in mathematical details, I strongly suggest to you to read the books from 𝗙𝗕𝗢𝗀𝗀 and 𝗙𝗎𝘀 There is also an online complete version of the deep learning book online. Well, this general approximation theorem shows that under very general conditions, let's say that it is okay if the function p as a function of the feature is simply a continuous function. To be more precise, it can be demonstrated also in more general condition, but it is okay for now to talk about continuous function. Well, this theorem can demonstrate that with the desired accuracy, we can approximate any function of this kind with a multi-level neural network. The only condition is that it has to have nonlinear activation function. If this is true, and you can check on the book, for example, that I've shown on this slide, the question that immediately comes out is, okay, if we can approximate every function of this kind with a neural network, why we haven't already used everywhere neural network for a long time? Well, the simplest answer is that neural network in the past has not always proved to be the most convenient algorithm to use. Most convenient in the sense of the algorithm with greater efficiency and effectiveness. So with less computational resources, less training time, could bring the best result. But, and this is the first important conclusion, in the last, let's say, 5 years, things have changed profoundly. And in fact, today we are surrounded by real-world application of neural network. So let's make one step forward. What are the reasons why we can use today effectively neural network? Basically, I've chosen 3 points. First of all, availability of large data set for training. The second one is the availability of more powerful algorithms to train the network. And third one is the availability of large specialized computing power, especially in the cloud. So I want to go with a little detail into this point. Availability of large data set, what does it mean? This picture is taken from a book. It is available online by a well-respected researcher in the field, Andrew Ng. Basically, this picture shows that differently from the traditional machine learning algorithm, let's say logistic regression, only with neural network, you can increase your performance simply using more data to train your algorithm. So, for example, the great success in the field of image recognition has been due to the ImageNet project, which has collected millions of images with labels to be used to train large and powerful neural network. Second, availability of more powerful and sophisticated algorithms. The network that were used until the late 90s were basically fully connected network with a few layers. The great success in the field of image recognition is due to great progress made with the convolutional networks, which use spatial filters, whose parameters are learned from the network during the training. Today, we use convolutional network even on our smartphone with hundreds of layers. And another field in which amazing progress has been made in the last 2 years is the field of the natural language processing. Let's think, for example, of neural machine translation, NMT. Today, we have technology to translate in real time between dozens of different languages to understand from a sentence what the request is. Well, all of these have been made by moving from the use of heavy recurrent neural network which required enormous computational power, to the use of attention mechanism and the so-called transformers. This picture that is taken from another famous white paper that you find online on the archive site that is titled "Attention is All You Need," shows one of the first examples of the transformer architecture that is at the heart of a very neural network used for neural machine translation. Then there is transfer learning. Transfer learning, what does it mean? Basically, it means that you can start from a network trained on a general data set. In this example, on ImageNet. And if you want to train the network on your specific data set, you can keep only the convolutional base of the network and change only the classifier, doing a fine tuning. So let's make a concrete example of the application again in the healthcare of transfer learning. For example, if you want to develop a model to recognize from a photo of a pigmented lesion of the skin, whether or not it is a case of melanoma. Melanoma is a very dangerous kind of cancer that must be recognized early, otherwise it is very difficult to cure. You can start from a convolutional network trained on ImageNet that, by the way, contains cats, picture of cats, dogs, cars, but absolutely no picture of moles or melanoma. And then you can fine tune the model on your collection of skin lesion images. Model of this kind have been developed again at the Stanford University. And this is the first page of the article from of the issue from Nature, where the model was presented. The third point is the availability of large specialized computing power. Basically, in the training of a neural network, you have to execute billions of times a set of operations between multidimensional matrices called tensors. Today, there are specialized processors. First, they were called GPU because they started from the graphic vector processing. Now they are called tensor units, which are able to perform this operation with a very, very high level of parallelism. Imagine having in a single chip 10 of thousands of cores, yes, tens of thousands, working in parallel, specialized in performing the tensor operation. For example, matrix product, dot product. And imagine to be able to distribute the calculation needed for training on 10 of these processors. For example, the latest technology of this type that you can find, for example, on Oracle Cloud that's available, has been recently released by NVIDIA, is the NVIDIA A100. And what we see this day is that we can almost expect to double the capacity every year. So, these specialized processors are already available, but they still have high cost. Let's say that they cost around, the newer one cost around 12,000 euro. And worse, the progress in this field is so rapid that obsolescence is rapid. After 1 year, a modern GPU is old. And then these processors are needed only in the training phase of the model. So it is possible to quickly make calculations to decide that rather than having a very expensive workstation in your company, we're talking of price around 100,000 euro per server, it is better to use cloud environment based on GPU in which you pay only for the actual usage. And in the cloud, you can find, as also Corrado has pointed out, environment that provides all the Python libraries ready to be used. Okay. In a few minutes, I want to add some more detail to this general picture. We have arrived at the first important conclusion for all the points that I've briefly described. Today, almost always, it is convenient to adopt neural network. There is basically a single important requirement. The dataset for the training must not be too small. But you must know how to use well neural network. Let's add some details. First of all, there are some preprocessing techniques to be applied. Neural networks work only on numbers. Character strings must be therefore coded appropriately. Then neural network work well only with features with zero mean and a small standard deviation. Therefore, normalization must be carried out. There must be no missing data. In the past, let's say up to 1 year ago, the commonly adopted approach was to do preprocessing on the data outside the network, using, for example, libraries like Pandas and scikit-learn that probably you know well. However, this approach has a major limitation. There is actually the risk that after the training, when you then go to make predictions of a new data set, you don't apply exactly the same transformation steps. For this reason, the approach that is becoming more common is to incorporate all the preprocessing steps in an initial layer of the network. If we take, for example, one of the most used deep learning framework, TensorFlow, there is a complete set of features for this kind of preprocessing that goes under the name feature column API. Just to give you an example, if we have to code a categorical feature with a high cardinality, for example, 1,000 different values, it is absolutely not convenient to use the well-known one-hot encoding, but it's better to use a dense vector of embeddings. And you find already this functionality in the feature column API. And what is more useful, working with large data sets, this feature allows you to carry out preprocessing on the GPU with all the computational advantages. Another important point regarding neural network is that it is not easy to optimize the so-called hyperparameters of the network. There are many hyperparameters that must be set in order to get maximum performances. The number of layers, the level of dropout, just to make some example, the choice for the regularization function, and so on. Experience can drive your choices, but then you need to test many different combinations. In this task, you can be helped using functionality like the 𝗤𝘼𝘾𝗎𝐿 that as described, or using an open source library like Optuna, as in the example in this slide. What you will see using a combination of this kind of functionality, GPU, is that you can really reduce the time needed to train your network. One last thing. Neural network, as you have seen, are a very powerful tool, but are a little bit complicated. To close the lecture, a final advice: don't use your model as a magic black box. One of the subtle risks is that, for example, unintentionally, you can inject some bias inside your model. The problem of bias and the unfairness of the model is especially important if you are developing models to make predictions on individuals, and there is the risk that this model introduce, or worse, perpetuate disparity. What does really bias mean? Technically, it means that if you partition your test data set in groups based on some attributes, for example, gender, male or female, or other, or the race, on some of these subsets, the accuracy of the model is significantly lower than the accuracy computed on the reference group. And so when you develop your model, you want to test the model to be sure that it does not contain bias. And also, there need to be a way for non-technical people, the policymaker persona that is shown here on the left, to test your model, even if they are not technical people. A very nice toolkit for bias auditing developed by the University of Chicago is the 𝗤𝘀𝘍𝑒𝑡𝑎𝑠. 𝗤𝘀𝑒𝑡𝑎𝑠 provides both a Python library that can be used in the notebook during the development of the model, and also it provides you a web application that can be used on the prediction made by the model by a non-technical person in order to test for bias. And this is an example of the plot that can be developed using the 𝗤𝘀𝑒𝑡𝑎𝑠. The model in this case is a model to predict the hospitalization time for diabetic patients, and the red line shows that on the Asian group of people, this is on a data set taken from US, the false discovery rate, the ratio between the false positive and the predicted positive is much higher than the ratio computed on the reference group, that is the group of the Caucasian, the white American. So it is important that you are able also to explain the prediction of your model to your stakeholders, to the customer that has committed the model, and also to test for bias. So I think that I have finished my presentation. That's all for this evening on my side.
Thank you, Luigi.
In the meantime, I've put on chat the link to data visualization desktop, and this is the desktop version of Oracle Analytics Cloud. And I have also put the link to get from Oracle a free tier on Oracle Cloud, which you can try our cloud and have the access to autonomous database. For who has some question about the registration, normally Oracle asks some data in order to download the data, software. So you can fill the form and have the access to OTN and Oracle Technology Network in order to download everything to try our software. In the case of free tier in cloud, we ask for a credit card just to have a real evidence of the customer is asking for a cloud for free, but no charge will be done if you don't enable the charging of on your credit cards. You have for 30 days, I think, $300 to use on our cloud to enable all the services that are available on cloud in this budget. After this time frame, you can still continue to use autonomous database, some other stuff that are included in the always free tier. So you can use the cloud in order to test, for example, the Oracle machine learning in database, or eventually data science service that leverage on Python and open sources framework that you can try on our VM or GPUs that I mentioned by Luigi. Thank you.
Thank you, Corrado, and thank you, Luigi, for your presentation. I don't know if there are any questions. No. So before leaving you,
I have a question.
Okay, okay, perfect.
Yeah. For Corrado, I think. Yeah. If there is the possibility to add some custom algorithm inside the platform, I refer to the first part of the presentation where there are several machine learning algorithms, etc. So,
at the moment, for a database, we have limited to 𝗙𝗫𝘘𝘎𝗓 algorithms because for security reason, we at the moment don't allow to download extra packages because it could be a vehicle of malicious software. In the case of data science, that is our open source managed services based on Python. In that case, you have a list of conda environment, TensorFlow, and normal packages, but you are free to download also other packages because you have a virtual machine without data, so there is no problem in terms of security, and you can upgrade the environment that we provide for free together with OML, AutoML algorithms that you could find also in that platform. I've shown only the AutoML and other algorithms related to database because we haven't enough time to show everything, but you can find also open source algorithms in virtual machine managed by us inside our OCI data science service that is available in cloud, and you could try for free with our subscription, always free.
Okay, thank you.
You're welcome.
Thank you, Corrado. Any other question? No. So thank you, guys. Thank you, Luigi. Thank you, Corrado, again. Before leaving you, I'd like to share the possibility to start a career in Oracle Italia. In fact, there are open positions for internship in the consulting tech. If you want to try to join us and to apply, you can send an email to 𝗙𝗕𝗢𝗀𝗏 with your CV. And you can find the address in the chat. I'm going to share with you right now. And thank you so much again to you all, and have a nice night. See you soon. I'm going to share with Alex also the record of the webinar.
Okay, thank you, Oracle. Thank you, Michela, Corrado, Luigi, and Rossella. I will upload the record on YouTube, as I said in the chat. So I will write to you in Telegram channel to send to you the link. And well, thank you again.
Thank you.
Welcome. Thank you to you.
Thank you. Bye.
Bye, guys.
Bye.
Have a nice night.
Have a nice evening. Bye.
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 Bye.